So this is the next example. To find the Fourier series expansion of the periodic function of period 2 pi. So the function is f of x equals to x squared, x defined from minus pi to pi. And then to use the result we get for the Fourier series to find the exact value of the series, 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared plus other several terms, taking the same form. Can we begin?
Wait.
Okay, good.
We can proceed.
Oh, good. So the first thing, are we able to clearly specify whether the function given is even or odd? So and the best way to do that is to sketch the function in the specified interval and see whether it is obeying the properties of even or odd. So solution. So let's start by sketching. This is my x. This is my y, 0 minus pi. And then this is pi. So when I put 0 into the function, I get the f of 0 is 0. If I put minus pi, the function becomes
minus pi
Pi
squared.
squared.
pi squared. So pi squared, let me say that pi squared is somewhere here. So I have a point here. And then when I put pi itself, I also get pi squared, okay? So this is simply a quadratic. So I'll have that this graph shows or that does it obey the definition of evenness, or does it show the definition of evenness of a function?
Yes.
Yes.
Yeah, because we can see that the graph is symmetric about the y-axis. So this function is an even function. So f of x equals to x squared in the interval minus pi to pi is even. So which means the Fourier series
Cosine.
is cosine, simply cosine, yes. F of x equals to a naught over 2 plus summation n from 1 to infinity of an cosine of nx, where a naught would be 2 over pi, 0 to pi of f of x dx, and an is 2 over pi, 0 to pi of f of x cosine of nx. So the bn is not there because it's 0, since the function given is even. So a naught will be 2 over pi, 0 to pi of x squared dx. So when you integrate to x squared, we get
X cubed over 3.
x cubed over 3. Now put in the limits and let's see. What will be the value of the a naught?
Two pi squared.
2 pi squared over 3.
Correct. 2 pi squared over 3. So then we are only remaining with an, and then we'll have the final answer. So an is 2 over pi, 0 to pi, f of x is x squared times cosine of nx dx. So which integration technique do we apply here?
Integration by parts.
Integration by parts. But then now I want us to use the tabular integration, which is just a special case of integration by parts. So the question is now to integrate x squared cosine of nx dx. Let us use tabular integration. I remember tabular integration is a special kind of integration by parts, which says that if I have to integrate u dv is the same as u naught v naught minus u1 v1 plus u2 v2 minus u3 v3 plus u4 v4 minus so this is the formula for tabular integration. It's just a special case of integration by parts, whereby the u naught and v naught are obtained in the first definition of the integration by parts, and then the u values are obtained by differentiation, while the v values are obtained by integration. So here, ui's are obtained by differentiation, while vi's are obtained by integration. And then we stop when ui gives us 0 value. The way we obtain the first values, the u naught and v naught, is the first step of integration by parts in the usual way. So you have to identify your u, and you have to identify your dv. So that first step in the integration by parts, what you will call u to carry out all the process of integration by parts, we give it the name u naught. And what you call dv, we call it dv naught. So that when we integrate dv naught, will give you v naught. And so other consecutive values of v's will be obtained by integrating the values of vi's, and other values of u will be obtained by differentiating the ui's. So this is what I mean. Like in our present problem, we have x squared cosine of nx dx. So in most natural way, the process of integration by parts will say let u to be what?
X
squared.
X squared. And dv to be?
Cos nx dx.
Correct. Cos nx dx. So this is what we'll do in the process of integration by parts. And actually, we pick it from that point of view. But the only difference we do now, we'll say what we are calling u, we give it the name u naught. And what we are calling dv, we call it dv naught. So this gives us u naught becomes x squared. And for you to get v naught from this point here, you have to carry out integration of this function cos nx dx. So what will be the value of v naught when you integrate cosine of nx dx?
Minus n sin nx.
Okay, so it's not differentiation, it's integration.
1 minus 1 over n sin nx.
So when you integrate a cos function, do you get a negative sign or just get a positive sign?
Positive. I think it's positive.
So it's just positive. So your answer is correct, but remove the negative sign. So when you integrate a cosine function, you get a positive sign. You get a negative sign if you are doing the process of differentiation. So that is a v naught. So u1, you now differentiate u naught. And when you differentiate u naught, what do you get?
X.
You get 2x. And then v1, you integrate v naught. So what do you get?
Negative cos nx over n squared.
Correct. Negative cos nx over n squared. Good. Then you go to n equals to 2. So u2 is the derivative of u1, which will give us 2. v2 is the integral of v1 with respect to x. So when you integrate this,
Negative sign nx over n cubed.
negative sign nx over n cubed. Then u3 is the derivative of u2. That gives us
0.
0. So because this is going to give us 0 and we'll need a product of u3 times v3, we don't even have to struggle with the v3, because at the end of the day, those things are not going to help us. From that point onwards, the products will always be giving us 0. So in fact, we don't have to calculate v3. Or if you like, you'll have to work out the integral of v2, which will give you cosine of nx over n power 4. But this is even not necessary, because at the end of the day, we'll need to multiply u3 and v3. Because u3 is 0, then times v3 is 0. So that term is not going to make any effect on the pattern. So we stop at that point. So therefore, you'll say the integral of x squared cosine of nx dx is going to be u naught v naught minus u1 v1 plus u2 v2. The rest of the terms are not necessary, because every ui value will be 0, so the product will be 0. So that's the stopping point. So when we say u naught times v naught, we'll get x squared times sine of nx divided by n, and then u1 times v1 has negative sign, but negative positive. So plus 2x cosine of nx over n squared. u2 v2 is negative twice sine of nx divided by n power 3. So which means that we were interested in calculating, so 2 over pi integral from 0 to pi of x squared cosine of nx dx will be 2 over pi into x squared sine nx over n plus 2x cosine of nx over n squared minus twice sine of nx over n cubed. X runs from 0 to pi. What will be the value of the lower limit?
Zero.
It will be 0, because where there's x, when you put 0, you get everything will be 0. So the only thing that matters over pi squared sine of n pi over n plus 2 pi cosine of n pi divided by n squared minus 2 sine of n pi over n cubed. So that'll be the only value, because the lower limit will be 0. Now, earlier on, we discussed the general values for sine of n pi and cosine of n pi. So the value of sine of n pi is
Zero.
just 0. So n pi is 0. So this part will be giving us 0. And then we'll have 2 pi. Value of cosine of n pi
-1.
-1
1
power n, and then divided by n squared. So when you multiply, moving brackets,
Four times -1 power n over n squared.
correct, 4 over n -1 power n. So this is n squared, correct. So that is how our an looks like. So then the Fourier series will be f of x equals to a naught over 2 plus a1 cosine of x plus a2 cosine of 2x plus a3 cosine of 3x plus other several terms. So a naught is given by 2 pi squared over 3. So a1, when you put 1 in this formula, we'll get
-4.
So we'll get -4 over 1 squared, then cosine of x. When you put 2, sign will be plus. Okay?
Yes,
Yeah, so
yes.
plus 4 over 2 squared, cosine of 2x. When you put 3,
Negative sign.
negative
4 over
4
3
over
squared
3 squared, cosine of
plus 3x.
3x. Then next will be plus
Positive sign.
positive sign. So
4, yeah.
4 over 4 squared,
4 squared
cosine of
x.
4x. Next term will be -4 over 5 squared, cosine of 5x, plus other several terms. So a half of 2 pi squared over 3
Pi squared over 3.
pi squared over 3. So I can factor out -4. Then my first term will be in brackets,
Cos x.
cos of
Cos
x.
x
Next term will be
minus.
Minus.
4.
Yes, cos 2x over 2 squared.
4. 2x.
Okay, so just writing, so in terms of square, so that because you know in this problem there was a series whose value were to find,
Yeah.
and
Yeah,
the way they were
yeah,
writing those terms, they were just square. So let's not simplify, let's just have the structure of similar to the series that we'll evaluate finally. And then plus
Cos 3x
cos 3x
over
over
3 squared.
3 squared. And then next term
And minus.
minus. So
Cos
we'll have
4x
cosine of 4x over
4 squared.
4 squared, then plus other several terms, okay? So this is the required series. Then we remember in the same problem, there was a series whose exact value we have to find. So we have 1 over 1 squared.
So before you
Nine.
continue, could you scroll up a bit?
Okay. Tell me when to stop.
The
Okay.
Could you kindly explain how you see where you've crossed and written a 0 for the terms to the left and to the right? Could you explain how we got those zeros?
So sine of n pi is always 0. So that's why where the sine of n pi is 0. So you can try with your calculator. So when n is 1, so sine of 180, put n equals to sine of 360 degrees, sine of 720 degrees, etc. You'll always get that the value will always be 0. So that's why we are saying that this term will be 0 and this term will also be 0.
That's all. Thank you.
Okay. So the series we have to find is 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared plus other terms. And I told you to discover how you are supposed to evaluate such kind of problems. You use the trigonometric terms you have in your final answer and see how you can play around with the values of the argument x to see which is the most suitable value when you substitute into the Fourier series expression. You can get exactly the same series whose value you are looking for. Then by the way, there is no mistake by even putting here 1 squared. It doesn't change the value. Just to appreciate the way the denominators of the square bracket look like is exactly the same way the denominators of this series whose value we have to find look like. And actually signs are rhyming. So the biggest thing is to determine which value of x will give cos of x to be 1, also cos of 2x to be 1, also cos of 3x to be 1, also cos of 4x to be 1, etc. Which value of x should we fix for that to be result in general for all those terms?
Pi over 2.
Pi over 2. But cos of 90 degrees is 1. Remember, these are cosine function, not a sine function.
0.
Is
0.
yes,
0.
cosine of 90 is 0, so that will not help us.
2 pi.
2 pi. So 2 pi.
Oh, we can fix 0.
Yes, please. Before you start struggling, please, before you start complicating the problem, try to think of a very easy way of doing the problem. Remember, our objective in engineering and objective in mathematics is to be very, very smart. Smart in such a way that we are very lazy. We don't want to struggle, but at the end of the day, we have to ensure that the shortest route we are picking is a route that gives us the answer in general also. Do you see that when you fix x for 0, that result will always be 1?
Yes.
Cos of 0 is 1. Okay? cosine of 0 is 1. And so reason as
Pi.
well, probably
Six
maybe
X is pi.
even 2 pi will work. I'm not sure, probably whether 2 pi will also work, but I'm picking a value. Remember, at the end of the day, I'll have to come and fix that value in this function. And I have to fix that value if it's in the domain of definition. Remember, this value was defined for minus pi to pi. So I try as much as possible to confine myself within the domain of the function. Are we together? So 0 is actually a perfect candidate for this. It will always give us 1. And that 0 is between minus pi and pi. So whose value we can always calculate because the function is defined in that domain. And 0 is from minus, can be obtained within the interval given, minus pi to pi. Okay? Are we together?
Yes.
Yeah, so we fix x for 0. It is going to make us get the answer or reduce this expression for Fourier series into a very easy expression involving the series we have to find. So when we let x to be 0, we'll have f of 0 equals to pi squared over 3 minus 4 into cosine of 0 over 1 squared minus cosine of 2 times 0 over 2 squared plus cosine of 3 times 0 over 3 squared minus cosine of 4 times 0 over 4 squared plus other several terms. And what is the value of f of 0?
0.
0.
F of 0 is 0 because we are going to have 0 squared, okay? Because remember, f of x was defined as x squared. So when you say f of 0, we are going to square 0, which is 0. So we are going to have 0 equals to pi squared over 3 minus 4. This will give us 1 over 1 squared minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared plus other several terms. I know you are very serious
Tired. We are very tired.
students. Yes?
We are
So
very
finally,
tired.
the answer is
Pi squared over 12.
pi squared over 12, correct. Pi squared over 12 is the final answer to that given problem. So all that infinite series reduces to pi squared over 12. So this now I would like you to go and this is not an assignment. It's part of a continuation of this. So discuss on the following. So the first one, what we call half-range expansion. And B, change of interval. So change of interval, I mean, we have actually been confining ourselves from minus pi to pi in the definition of the Fourier series. What happens when we go to the interval, say, minus L to L? How does the Fourier series expression look like? And half range means what happens if we are given a function defined from 0 to pi, and we are asked to find its Fourier series, its Fourier cosine series or Fourier sine series. So discuss on those two aspects and probably give one example in each case. I'll be sharing supporting documents to help you do that. And prepare for the CAT. The CAT will test on 3 areas. One, this CAT will be physical. First is Laplace transform. And the inverse Laplace transform. Number 2, and then number 3, and I know we are used to each other for the last 3 years. So you probably have you should have known how to predict my setting style. I'll actually concentrate more on areas that I didn't do, that I give as an exercise in class. So ensure as you prepare, ensure that you check all the areas, especially those things that were given as exercises, is where I'm going to concentrate more. So this will have 10 marks, this will be 20, this will be 20. So the CAT will be out of 50. So I wish you all the best so that